So far in all the previous example, we focus on how to get dy dx. We focus on how do we use indices, how do we use algebra, so that it will match the structure in formula number 2, so that we can be getting our dy dx correctly. So in this example, we come to the real use of the dy dx. Because in this example, right, you're asked to calculate the gradient of tangent to a curve and at a specific point. So you read the question again, you are supposed to calculate the value of the gradient to a curve at a specific point. So you might want to formulate some idea in your head first. So the idea that I will formulate will be something like, I got a graph. Okay, I just randomly draw a graph. So to me, this one is a curve. So how the curve looks like, it doesn't matter. Okay, you'll just, maybe I just draw something. So this is how the curve looks like. And then I got a specific point here. So this point is 111. So what am I interested in? I'm interested in the tangent. So if I have drawn a straight line here, what would have been this gradient? So this is the tangent that we draw. And then I'm interested in the gradient. So the first thing to do, of course, I will need to find my dy dx. So if you're going to be finding your dy dx, then you got to observe your expression for y. If you observe, this first term is already ready for differentiation because x and the number is already side by side. I can already differentiate. Whereas this one is not ready for differentiation first. It's not ready because x is in the bottom. So in fact, you need to make sure both terms are ready first. So you need to make sure both terms are ready for differentiation. Then you can do your differentiation. So you apply your indices so that both are ready for you to apply your formula number 2. So it will be a wrong presentation if you differentiate one of them and then you use indices. So in a while, I show you the wrong presentation. So let me show you the correct one first. So the correct one should be you apply indices first, then you do a bring down power minus power, bring down power minus power. Okay, so try not to write with a negative power. So this negative power will be returned to the denominator. So that will be your dy dx. So your dy dx is already created. So you realize that dy dx is a formula. So it is a gradient formula that is dependent on the value of x. So if you sub x, different value of x, you will be getting different value for gradient. So right now, you should sub the x coordinate. So the gradient is 18. Okay, so you sub x, you do not sub what? The y coordinate. Some people will sub the y coordinate. Okay, but in some question, it can be quite tricky. Some question wouldn't give you the x coordinate directly. Some question actually give you the y coordinate. So if you are given the y coordinate, but the gradient formula depends on the x value, So you got to use the value of y to find the corresponding value of x. So there will be questions like this for you to explore. Okay, and just now I mentioned wrong presentation. So what do I mean by wrong presentation? So there will be some students who do this. So some students will be like this. They bring down power, minus power. And then this part, they change to indices. So some student will do something like this. So they will do a dy dx like this. So why is this wrong? Okay, then the student will do something, then they will continue. So the student will just continue. Eventually, the student will get the right answer. But actually, the teacher will penalize for wrong presentation. Okay, so eventually, right, this student will get the same answer. But then, right, there is considered wrong presentation. So why is it considered wrong presentation? Because the student applied the formula. But here, the student apply indices. And then the student apply formula here. So you cannot apply the formula and indices in such a half-hearted way. So when you want to do differentiation, right, straight away, you apply the formula. So if you take a look, I apply the formula directly at the same time for both terms. You cannot be doing one differentiation formula, another one is indices, and then you call that dy dx. Eventually, you get the same answer, but then your presentation is actually not correct. So hopefully you can understand this idea. And always remember, the dy dx that you create is a formula. The formula is dependent on what is the value of x that you are substituting inside. And sometimes you are not given the direct x coordinate to substitute. You might be given a y coordinate. So you cannot anyhow sub a y coordinate because the gradient formula doesn't depend on y coordinate. If you are given the y coordinate, you got to come back to the original curve, use the y coordinate to find the x, and then you sub into the gradient formula. So later on, there will be questions that explore this.